Good morning, dear students. Last week we have done certain activities as well as we have learned about different type of mixtures, homogeneous, heterogeneous, solutions, saturated, unsaturated solutions, diluted solution, alloy, right? Now, today we are going to start with the solutions. Generally, mixtures of two or more liquids are termed as solutions. And if we say, we have already learned in the last video, solution is made up of solute and solvent. Even the concentrated and diluted solution also we have learned. Now, basically, solutions are classified in three categories. They are true solution, suspension solution, colloidal solution. True solution is also just to say solution. So, today I will explain you what is true solution, its characteristic, and suspension solution and its characteristic. Please listen to the video properly. So, the activities which you are supposed to perform will be easy for you to do and observe the activities, right? So this time it is your time to do the activities. In the previous videos I have done the activities. Now first, a homogeneous mixture of two or more miscible liquids or solid is called a true solution or solution. Homogeneous mixture. So example I have given: glucose powder, sodium chloride, that is NaCl, common salt, namak, copper salt, CuSO4. If you have remembered in the last week video, sky blue color solution which we have prepared, it is of copper sulfate. So when this type of powder are dissolved in the water, you will get a true solution, a complete homogeneous mixture throughout, from top to bottom. If you will see, the solute particles are trapped into the spaces between the solvent molecules. If you will try to observe it properly, even then with your naked eyes or even with the microscope, the solute and solvent molecules cannot be differentiated. The size of these solute particles is very small. If I say in the terms of some measure, it is 10 raised to minus 10 meter. 10 raised to minus 10 meter, it means it is 10 raised to 10 part of 1 meter. 1 upon 10 raised to 10. So very small. And as they are very small, they are not separated by the filtration method, because the particles of solute and solvent are very small compared to the pores of the filter paper or filter cloth. The solute particles in a tree solution do not settle down. Once you prepare the solution, stir the solid which we have added it, and if it is a true solution, then those solute particles will not settle down. That is, the solution is stable. And if you allow a light beam of light, a certain path of light to pass through that solution, it will not scatter a beam of light. This is about the true solution. On this basis, you will have to perform the activity. So now please be attentive for suspension also. Suspension solution. The word suspension means hanging. Let me just clarify first the meaning. Suspended means floating or hanging, like without any support. If something is hanging with the support in the solution without any support, when the particles are floating throughout, that means they are seeming that they are hanging. Such type of solutions are called suspension solution. So here what happens? The suspension solution, the particles remains in the solution floating. It is not homogeneous, it is a heterogeneous mixture of two or more very fine particles of solid dispersed in any medium, liquid or gas. Dispersed, that means distributed, is called a suspension solution. In suspension solution, fine particles of the solid remains suspended in the medium. That means those solid particles, like true solution, it will not completely disperse or it will not completely mix, but somewhere they remain floating throughout the solution. Example is muddy pond water, chalk water, coarse lime particles in water. Coarse, that means not smooth but rough, karkara, lime particles, matlab the calcium carbonate, chuno, right? Smoke, a gaseous form coming out of chimneys in the air. It is also a suspension. The smoke particles remain suspended in the air. So it is heterogeneous mixture and a suspension solution. So what is the characteristic? It is heterogeneous mixture. Particles in the suspension solution can be seen with our naked eyes and even with a simple microscope. The solute particle here is 10 raised to minus 7 meter or larger than it. 10 raised to minus 7 meter, that means out of 1 meter it is 10 raised to 7 times smaller. It can be separated by filtration method. 10 raised to minus 7, it means it is larger than 10 raised to minus 10. When the negative number is there, that is integers, smaller the number, greater with the value. So 10 raised to minus 10 and 10 raised to minus 7, this one is the larger. The most solute particles in a suspension solution settle down. However, some very fine particles remain suspended in the medium. So the solution is unstable. If you will take a soil or a chalk and if you will dissolve, then after some time you will see the certain particles settle down and certain particles remains suspended. This is a suspension solution. If a beam of light is passed through this solution, it will scatter the light. When I say scatter the light, that means it will allow the light to pass through that solution and you can see the path of a light from the source even in the solution and out of the solution. Now let us see. I have given you the glance of the activities and this you have to do and then you have to write the observation, right? So you will take 2 glass. In it, one of the glass you take either sugar powder or salt powder in a water and stir it. Stirrer, that means with help of a spoon you will stir it. Then wait for some time and observe. Write your observation. Take another glass, take in it chalk powder or mud soil and stir it. After stirring it, stand for a while, let it rest for a while and then observe both the glass A and B. Write your observation and identify the solution, whether it is suspension or true solution. And one more activity. Same glass A and B with the sugar or salt solution and here with chalk powder or muddy water. Take a torch or any source of light and allow to fall a light through it. If the light is allowed to fall from this solution, both the solution from this and from this, and you have to observe whether this light is seen in this glass path and even after it, or it is seen here, not here and then here. What you are observing in both this solution, write down that observation and confirm the characteristic, that whether it scatters the beam of light or whether it does not scatters the beam of light, right? And then in next week you will upload your answers through the WhatsApp. Thank you.